So this video is talking you through the most complex level of the projectile one, right? So the scenario is, you're at home, you live in an apartment on the first, second, third floor of a building. You have a balcony, and below you is a swimming pool. And the question that you have been posed is, can you make the swimming pool? What speed will you hit the swimming pool at? And what will the angle of impact be? So there are various aspects to this question. Looking down the balcony, I can see that there's 8 floor tiles here, and that they're all 1/2 metre wide. So this distance here is 4 metres. You're on top of the second floor. So we're saying that each floor is about twice the height of me. So it's about 4 metres per apartment. So 8 metres up. Yeah. The best angle to make the most distance is to launch yourself at 45 degrees from the horizontal. That makes the most distance. And then we said that Usain Bolt can run at like just over 10 meters per second when he broke the world record. Therefore, we're probably slightly less. We're going to call it 7 meters per second, right? So this is our scenario, yeah? And we're going to try and solve everything about it. The first question is, will you make the pool? Will you make it? Will you make it? The next one is the velocity, so will you survive it? And then I guess the third bit, the angle of impact, would kind of tell you whether will you hit the bottom. But what we're actually asking here is S horizontal, V final, and theta at the end, right? That's really what we're asking. So let's have a go at doing this bit by bit. What you've got in this motion, you've got 3 stages to this flight. You have an up bit, you have a down to the same, and then you have a down like that. So you can, if you want to, you can consider it in 1, 2, 3 stages of motion. You can do that if you wish. Or if you're disciplined with the positives and negatives, you can do every aspect of this. The first step is to break your launch into a horizontal and a vertical component. We said it was 7 meters per second, 45 degrees. Yeah. So we use Socoterra for that. And we say that the initial horizontal velocity is 7 cosine 45. I always remember that because the little angle thing connects the hypotenuse and the horizontal, so it's cosine. That's how I remember it. You can do it properly and use Socoterra, but I just remember, this is one of the most common things we do, so I just remember that. On the other side, it's then the other one, which is 7 sine 45. Yeah? This is U vertical, and this is U horizontal. Okay? Great. So we've got ourselves initial velocities, horizontally and vertically. So let's work out the time of flight first. Let's see how long it's going to take to go up and come back down again. right? So for that time, we're going to say that the initial, we're going to deal with the vertical, and we're going to work out time. You can do that grid that I talked about previously, where you do horizontal, vertical, and you do S, U, V, A, T. That does work here. Horizontal displacement, we're talking about a minimum of 4 meters. Vertical, we're talking about a minimum of 8, or it's down, so you can call it -8. Initial velocities, horizontal, we've got 7 cosine 45, 7 sine 45. In the horizontal, acceleration is 0, so again 7 cosine 45. We don't know that, we're going to find it. We know that this is down and it's 9.81, it's gravity. So we've got some information. We've got 1, 2, 3 knowns and 1, 2 unknowns in the vertical. So let's do let's do time. So the time, let's do S equals ut plus a half at squared. Although, because u isn't 0, we're going to end up with a quadratic, aren't we? Yeah? We want to know v eventually, so maybe it would be easier to find v than we're not doing a quadratic. You can do the quadratic, it will get you the answer. One of the 2 answers in the quadratic will be negative and one will be positive, so you can kind of dismiss one of them straight away. But actually, if we do v squared equals u squared plus 2as, we can get v and then we don't have to use a quadratic. So I'm going to do that. So v squared equals u squared plus 2as. You get rid of a little bit of our drawing because
7 cosine 45 is 3.67.
I'm going to leave them as numbers like that. It's just sometimes it's easier for typing. You can calculate a numerical value if you want, but yeah. So v squared equals u squared plus 2as. So v equals the square root of u squared plus 2as. So that's the square root of 7 sine 45 squared plus 2 times minus 9.81 times minus 8. So we can get rid of the minuses, can't we? And then hopefully we should just be able to plug that straight into a calculator and get an answer if I knew where my calculator was. Which I don't. If you're watching at home, just calculate that. I have my 2 unseen assistants doing it. In my head, I'm thinking what the answer should be is going to be 80-ish times 2 is 160. Someone just told me that was about 8. 8 squared is 49, so 200-ish. Square root of 200, I should be looking at an answer like, I don't know. Square root of 7 sine 45 squared plus 2 times 9.81 times 8. I get 13.9 meters per second. Okay? So 13.9. Yeah, that means I can use any other equation to find t. nice simple one is always that v equals u plus at. So 13.9, but remember the 13.9 is going down, whereas it started going up, so we do need to say that it's a negative 13.9. So minus 13.9 equals 7 sine 45 plus minus 9.81 t. Okay, let's rearrange that. Let's multiply through by minus 1. So that does that. And then move this across. 13.9 plus 7 sine 45 equals 9.81t. So divide it by 9.81 and we have ourselves a value for t. So 13.9, I've not erased my calculator, so I still have the number, plus 7 sine 45 divided by 9.81 is 2.2 seconds, or 2.02, sorry. 2.02 seconds. Alright, so we've solved everything. So it takes 2.02 seconds to go up and then come back down again. Right? The next logic test to answer the first question, will you make it? Well, if you're travelling across at 7 cosine 45, you need to do 4 meters. So this is kind of like our question mark, really. Do we get more or less than 4 meters? Speed equals distance over time. So displacement is speed times time. So 7. So your answer times by 7 cosine 45. I get 7.4 meters. So actually we end up going 3.4 meters into the pool. So as long as the pool is less than 4 meters, we're all good. We're going to land here. We're going to land 7.4 meters across, yeah? Which is bigger than the 4 needed to reach the swimming pool. So we don't hit the tiles, we hit the water, which is a good result. It's a lot more comfortable. So will we survive? What will be our final velocity? Well, we've calculated the final velocities both in horizontal and vertical, so we know that we're coming in like this, and we know that vertically it's 13.9 down, and horizontally it's 7 cosine 45. So let's find our final velocity and our angle of impact. We're just going to use SOHCAHTOA to work that out. And the other one, Pythagoras, isn't it? So V final squared equals 13.9 squared plus 7 cosine 45 squared. Yeah? So I get V final to be the square root. I get 13.9 squared plus 7 cosine 45 squared. Square root that answer. 13.96, so 14.0 meters per second is your impact velocity. And your angle, any one of SOHCAHTOA, sine theta, silly old Harry, so 13.9 over 14.0, theta is sine to the minus 1, 13.9 over 14, which is sine to, oh, that's not to the minus 1, shift sine, 13.9 divided by 14. that seems. Oh, I'm in radians. Mode. Well, how do you turn it out of radians? Whoop, that's not how you do
Yes,
it.
for degrees, for the time, you wait for the
Hang on, let me get the angle. Shift sine to minus 1, 15.9 divided by 14. Such a small number that I knew it was wrong. Okay, we're striking the water at 83 degrees. Yeah? So almost straight down, almost at 90 degrees. There we go. So now we know everything about that motion. We know strike angle, we know final velocity, we know how far we'll be away from it when we land, we'll know if we make it. The final part of like IB and A-level questions would be, in reality, will you make it? You're going to have a bit of air resistance, so you're not quite going to go 7.4 metres. But actually, let's say you lose 2 metres, you're still on 5.4 metres, you still make it. So even with air resistance, I think you would actually make it. Yeah? So yeah, that's projectiles.